Okay, so in this video, we are going to talk about the third and final way to write a linear equation, and that is using standard form. So quick review, we have learned slope-intercept form, which is y equals mx plus b. It's called slope-intercept because m is the slope and b is your y-intercept. Then we learned point-slope form. Point-slope form being y minus y1 equals m times x minus x1, where m is the slope, just like it is up here, and x1, y1 are a coordinate point, okay, which is similar to this. That's a coordinate point. It just is a very specific one that falls on the y-axis, where this is just any coordinate point. So our last form is standard form, and that is ax, and yes, the a, b's, and c's have to be capital, plus by equals c. Now, unfortunately, this a, b, and c don't mean anything. Like here, the b was a y-intercept, m was slope, x1, y1 were coordinate points. This a, b, and c, they really tell us nothing about the line. The reason we have slope-intercept or standard form is it encompasses all lines, where neither one of these are going to encompass a vertical line. So there are some rules with standard form. Rule 1, a can't be negative. The number that is in a's spot must be a positive number. So if it's negative, you're going to have to multiply everything by -1 to make it positive. B and C can be negative, just not A. A, B, and C must be integers. For that matter, A better be a whole number, not even an integer. In other words, you cannot have fractions and decimals here. If you do, then you're going to have to do that multiplying through that we've learned, where you multiply through by the denominator or by 10 or 100 to get rid of the decimals. Okay, so here's an example of an equation in standard form. (2x plus 3y equals 6). Again, that 2, 3, and 6, they're not an intercept, they're not a slope, they don't really tell us anything about the line. However, I can graph lines using this form. Okay, it does follow the rules because I have no decimals or fractions, and a is a positive number. So there's a couple ways that I could graph using standard form. The first is to make an XY chart, find 2 coordinate points, because all I need is 2, plot them, and draw the line. Your easiest coordinate points to find are your x and y intercepts. Okay, because a y-intercept is when our x value is 0. So I can just plug 0 in for x and solve for y, which is the easiest number to plug in and solve. And then my x-intercept is when the y value is 0. So I can just plug 0 in for y and solve. Okay, so if I plug 0 in for x, that's going to give me 2 times 0, which is 0. So basically, if I plug 0 in for x, that entire term goes away, and I'm left with really only solving this. And that means y is 2. So our y-intercept is 2. If I plug 0 in for y, kind of the same thing. 3 times 0 is 0. So that entire term goes away, and I'm really left with just solving that. 2x equals 6. Well, x has to be 3, so my x-intercept is 0. So those are 2 quick and easy coordinate points. I could now plot them. So there's my y-intercept. There's my x-intercept. Connect the points, and I have my line. Pretty easy to graph. Doesn't take too much work. My other option, if I didn't want to do this, is I could actually solve and put this in slope-intercept form, and then I could go ahead and graph it since we know how to do that. So to get it in slope-intercept form, I want y by itself. So I'm going to subtract 2x. So remember, these are not like terms, so you have 6 minus 2x. Now I'm going to divide by 3. So y equals, I want to do my 2 divisions. 6 divided by 3 is 2, minus, that side will be 2/3 x, because we do not want a decimal for slope. We want to be able to go down 2/3, not down 0.6 repetend. Now I'm just going to rewrite this. This becomes -2/3 x plus 2, and that is in slope-intercept form. So I would start at 2, go down 2/3, and be able to graph that from there. So those are kind of my two options with graphing something in standard form. Now, what happens if you're given something in slope-intercept form and you're told to put it in standard form? So for example, if I have to get this in standard form, remember, I need my x and y on the same side. Right now, they're not. So the first and easiest thing to do is to move that over, move that entire x term over. And I simply do that by just subtracting 4/5 x. So now I have negative 4/5 x plus y equals 6. So I have ax plus by equals c. However, remember, I can't have fractions or decimals, and a cannot be negative. So I need to multiply through, which we can do as long as we do it to everything, to get rid of the 5. So in order to get rid of the 5, what I want to multiply by is 5. Okay? Now, I also want to get rid of the negative. And how I get rid of a negative is by multiplying by -1. So what I'm going to do is just multiply by -5. Multiplying by 5 gets rid of that denominator. Multiplying by a negative gets rid of that negative. Now I have to make sure I multiply everything by -5. So here my negatives will cancel, the 5s will cancel. So I have 4x. This is -5y, and that is -30. So I have 4x plus -5y equals -30. Now I have it in proper standard form. Some people might go one more step and just make it 4x minus 5y. Both are correct. Let's try another one. Okay, so again, the first thing I want to do is move my x term over. So because that's negative, I'm going to add 1.2x. So now I have 1.2x plus y equals -5.4. So I have ax plus by equals c. So that part is correct. However, we can't have decimals. A is positive, so I'm good there. I don't have to worry about that, but I do need to get rid of the decimal. So because we want to move the decimal point over one place, we want to multiply by 10. But I need to multiply everything by 10. So this becomes 12x plus 10y equals -54, and I would be in proper standard form.